Hello, wonderful mathletes. It's Miss Gregory. I am coming at you with week 7, May 2020, the coin flip data observation, which is marked 6.05. We are trying to give you a little bit of guidance here on what to do so that this will be a very easy grade for you. So moving on to the next slide. In the lesson, which you still should read the lesson, this is for help with the assignment that comes after reading the probability. So you are dealing with some new vocabulary. The probability of finding an event. You are to find the theoretical probability for some questions, and you are finding the experimental probability with others. So having this screen open or your lesson on probability open, or the notes that were made with Miss Dannon from her document that was posted. Okay, you have several sources that you can use to remind you what is theoretical probability, what you expect should happen, versus experimental probability, which is also called relative frequency, what actually happens when you perform the experiment. So with this assignment, you are supposed to flip not just one coin, you are flipping 2 coins. But with this example of theoretical probability, if you flip a coin, unless it's some trick coin, there are only 2 sides. You would either land on heads or you would land on tails. So you could land on heads 1 out of 2 times since there are only 2 sides to a coin. Head is on one side, tails is on the other side. So if I flipped the coin 10 times, I would expect the theoretical probability to be 5 times heads and 5 times tails. 5 plus 5 is 10 total coin flips. Half the time heads and half the time tails. That is what should happen. It might not actually happen exactly that way. If I were to experiment and actually flip the coin 10 times, I could record my data. All right, then we have experimental probability, what would actually happen, and record your data. So the number of times the coin landed on tails over the number of times you tossed the coin. So if I flip 2 coins 25 times, and it landed on both 2 tails 5 times, the experimental probability would be 5 out of 25 that both coins landed on tails. 5 out of 25 could be written like a fraction and could be simplified, and we always want to simplify the fraction. Percent is usually how they are going to ask for probability, but technically you should be able to convert fraction, decimal, percent, and always have the fractions simplified. So 5 out of 25 times that both coins landed on tails would be simplified to 20% probability, 2/10, or simplified fraction 1 out of 5. Okay, moving on. How to show work for finding probability. This is key to getting all of the points that you would like for the assignment. The rubric requires that you show your work, meaning what did you multiply or maybe you added and found for the probability. So this is taken from the document Ms. Dannon made. If you are tossing 2 coins, which is your assignment, you are now going to use what's called compound probability. More than one thing is happening. You are not flipping 1 coin, you're flipping 2 coins. 2 coins makes it compound probability. However, the effect of flipping the first coin does not affect how the second coin lands. So it is independent compound probability. So here's a description briefly of what you need to do. For finding the theoretical probability of compound events, let's consider both coins landing on heads for this example. The first coin is flipped, lands on heads. The second coin is flipped, also lands on heads. So you're finding the probability of tossing heads on one coin, and you multiply it by the probability of tossing heads on the other coin. Well, we've already learned that if we flip one coin, it has a 50-50 chance of landing on heads. So 1/2 of the time, the coin would land on heads, times another half of the time it would land on heads. We are multiplying 1/2 times 1/2 because we have two coins. 1/2 is the probability of flipping the first coin landing on heads. 1/2 is the probability of flipping the second coin and landing on heads. When I multiply these fractions, 1/2 times 1/2 equals 1/4, or I could write the fractions as a decimal and I would get 25 hundredths. Changing the decimal to percent is 25%. These are all the same value, 1/4, 25 hundredths, and 25% written as a fraction, a decimal, and a percent. Again, notice that the fraction is simplified. Okay? Please know that a toss landing heads and tails is the same as tails and heads, meaning the order doesn't matter whether you flipped the first coin and landed tails or you flipped the first coin and it landed heads. The order doesn't matter. It just means you got one of each. One coin landed heads, one coin landed tails is the same as changing the order and one coin landing on tails and one coin landing on heads. So therefore there are two outcomes here of heads and tails, one each. All right, let's look at the sample space. This may help explain this a little easier, and you need to think about this sample space when you are trying to work question numbers 1, 3, and 5. Some people are getting confused thinking if you look at the table, there's 3 columns, so there must be 3 outcomes. That's actually wrong. There are 4 possible outcomes. If you look here at this graphic image posted, this is called the sample space. There are 4 possible outcomes when you flip 2 coins. For example, you can flip coin A, then you can flip coin B. If you flip coin A, it could land on heads. You can flip coin B, and it could also land on heads, meaning the outcome is both coins land heads. Or you could flip coin A, and it could land tails. And you could flip coin B, and it could also land tails, meaning both coins land on tails. This little part in the middle is the tricky part because there's actually 1, 2, 3, 4 outcomes. 2 out of the 4 really mean the same thing. 2 out of 4, if I simplify the fraction 2/4, I'd get 1/2. So I'm saying there are 2 times out of 4 outcomes that the coins, when I flip them both, could land one each, heads and tails. Because it could land heads, tails, or it could land tails, heads. And we said the order of that doesn't matter. So again, you could have both coins land heads 1 out of 4 times. You could have both coins land tails 1 out of 4 times. But heads and tails 1 out of 4 plus tails and heads 1 out of 4 would be 2 out of 4, which is 1/2 of the time. 1/2, that's the probability, okay? All right, onto your screen. So when you are clicking through the lesson, looking at the different pages, you are going to choose option 1, which means you need to click on the picture of the girl here with the coins. You do not want to choose this option. You can, but it requires much more work for you, and I know you don't like to do more work. So, moving on. Once you click option 1, do not be confused. At the bottom of this page, it is talking about regular credit and advanced credit. Just ignore all this. Do not pay any attention to this. This is your class. This is your assignment. There is no regular or advanced. When you get to this page, you should click here and choose option 1, and then you will see the questions that pop up. The questions, there are 7 questions. You need to either use the data table that is given, or you need to draw your own on a piece of paper, and you need to flip 2 coins 100 times. So you're going to flip coin 1, record the way it lands, flip coin 2, record the way it lands. Then you're going to go over to your table. Did both coins land heads? Put a tally mark there. Did both coins land tails? Then you would need to put a tally mark in that column. Or did you have a combination of 1 heads and 1 tails? Then you would need a tally mark for that. Okay? Notice that this would be your experimental probability. There are questions asking you for theoretical, which we just talked about how to find and show work for. And there are questions asking you for the experimental. The experimental is going to be what you record when you actually flip the coin 100 times. Make sure that in your list, in your table, on your paper, however you decide to record your data, make sure that everything adds up to 100 total coin flips, okay? The sum should be 100 after doing that. You're going to show how to calculate the theoretical probability, which was on a previous slide, by either showing that you multiplied or showing that you added the outcomes in the sample space. The last question asks you to compare your answers. What was the difference between the theoretical answers and your actual experimental answers? Why do you think it was different? And you've had a quiz question on a previous quiz asking about what would happen if you flip 1 coin. So this should be fairly easy for you. You are going to then submit your work. It can be done on paper as long as you write very neatly, or you can use a Word document. Okay? If you are using what Miss Dannon created, this will help you immensely. I cut and pasted her questions, and she's given you a little template to follow in order to answer the questions, okay? So I've made my table. It's turned out red and pink. Don't know why, but no worries. Whatever table you decide to use. You are going to have a column where you would mark with tally marks and then total up how many times you flipped the 2 coins and they both landed heads, how many times you flipped the coins and they both landed tails. And technically these are 2 outcomes. No matter the order of heads, tails, or tails, heads, you would record here. So remember, there's not 3 outcomes because there's 3 columns. Technically, there are 4, and this is 2 out of 4 outcomes. Again, write your tally marks, total them up. Make sure all 3 totals here equal 100. All right, so this is question number 1. What is the theoretical probability that a coin toss results in 2 heads? Theoretical is what should happen, what you expect to happen, not what you actually did in your table. So the theoretical is going to be going back to the slide here, the theoretical of landing on both heads, theoretical of landing on both tails, or the theoretical of landing on 1 heads and tails. Okay, so remember, go back to that screen. All right, and I'm not going to give you the answer, but you should think about what is the theoretical probability that if you toss coin 1, it would land on heads? What is the probability that you toss coin 2 and it lands on heads? Multiply that, get your answer. You can keep it as fractions, then change it to a decimal. Finally, you do need to put your answer as a percent. So you are literally filling in the blanks. Now, experimental probability means you actually performed the experiment, you flipped the 2 coins, and you are looking at your data here. What is the experimental probability that a coin toss results in 2 heads? Well, then I need to come up here and look at 2 heads, and whatever I recorded here, that number is going to go in this blank out of 100 coin flips. So I need to write that as a fraction over 100, possibly even simplify that fraction if I need to, change the fraction to a decimal, change the decimal to a percent. You know how to do decimal to percent. You've got a calculator to help you. Please reach out to one of your math teachers if you need help with this. Okay, back to theoretical, but what should happen if you flip 2 coins and both of them land on tails? So again, if both of them land on tails, the theoretical probability, okay, of one landing on tails, flip the second coin, landing on tails, multiply, fraction, change to decimal, change to percent. Okay, experimental probability that both of them land on tails. So I would need to go back up here to my chart and count and see how many times both coins landed on tails and fill in my blanks as I go across. All right, back to theoretical probability, what should happen, what I expect might happen if 1 coin lands heads and 1 coin lands tails. So again, back to my sample space, we're talking about this right here. There are actually 4 total outcomes, not 3. So there are 2 times that it could land on 1 each. The order is just changing. I went ahead and put both of these into 1 column, right? 1 lands on heads, 1 lands on tails. No matter the order, I wrote it here. So technically, I'm going to say the theoretical probability, how many times I could land heads, tails, get the fraction, change it to a decimal, change it to a percent. Again, if you are confused on this part, reach out to your math teacher for help. What is the experimental probability? Experimental means I'm going to look up here. 1 time heads, 1 time tails, and look at my number out of 100, change it to fraction out of 100, decimal, and percent. There actually is one more question. It's question number 7, asking you to compare the theoretical to the experimental. Okay, but if you have done all of your work 1 through 6, that will help you answer question number 7. So I hope that this has been helpful. Remember, when you go to do this assignment, you're going to click on option 1. You will want to refer back to this sample space as you are finding your theoretical probability. You may need to look back at how to show work, although the template filling in the blanks should help you with that. You may need to look back if you get confused and forget what is the difference between theoretical probability and experimental probability. And again, this document came straight from the one posted in the announcements for week 7 by Ms. Dannon. Thank you. You guys have a great afternoon. Get your math projects done and make 100%. Signing out, Ms. Gregory.